Hi, welcome back. I'm Naren, and in this video we will try to solve problem 1 of round H from Kickstart 2022. And the problem 1 is running in circles. So this is the description of the problem, and we will try to make some notes. The problem talks about Ada participating in a marathon, and for that she wants to practice in a circular track of length L. And there will be a machine which counts the number of laps. There is a starting point in that circular track, and the machine starts with a count of 0. And whenever Ada while running in the circular track, she crosses the starting point, the machine increments the count of the number of laps by 1. And there's a condition that the direction of crossing the starting line should be same as the direction when she started previously while crossing the starting point. So if in any condition Ada changes the direction of the running, then the machine will not count when she crosses the starting line. Instead, whenever she crosses the starting line in a different direction, that will be reset as the starting point, and now the machine will start counting whenever she crosses the starting line in the same direction. So the machine always remembers the last crossing of the starting line and the direction. So the machine remembers the direction when Ada crossed the starting line previously. So it always remembers only the last crossing of the starting line and its direction. And Ada doesn't run continuously. She might be taking different breaks, and the problem will have n different breaks. So among the n breaks, she will be trying to cover some distance. But there is no guarantee that Ada will be running in the same direction in all the n chunks of the running, and the direction can be clockwise or anti-clockwise in each of those chunks of the running that Ada will do. And in each of those n runs, the chunks of runs, the distance covered will be di in the I chunk, and ci will be the direction in that chunk, which can be either C indicating clockwise or A indicating anti-clockwise. And the problem definition is we need to find what is the number of laps reported by the machine that is counting. And the input to the problem consists of T, the number of test cases, and then L and N, L indicating the length of the circular track, and N is the number of chunks of the runs that Ada will be doing. And then in next n lines we will have D and C in each line, indicating the D for the distance covered by Ada in each chunk, and C indicating whether it is C or A, and which means either she is running in clockwise or anti-clockwise. So we will be having D1, C1, D2, C2 till D and Cn in the next n lines. And the output should be case hash T for test case colon space and LP, where LP indicates the number of laps counted by the machine. And about the limits, L and D can take value till 10 power 9, and N can take value till 10 power 4, and we can use in 64 for all these variables. And let's look at the sample. So in this sample input there are 3 test cases. We will try to pick the first one, which has 5 as the units of the L, which is the length of the track, and we have 3 chunks of runs indicating 8C, 4A and 5C. And in the right side we have the diagram indicating each of those chunks. The color maps like 8C, which is in red. We can look at the red circle for 8C and green circle for 4A chunk and yellow for 5C. So let's S be the starting point, and the central 5 lines can indicate the length of the circle, which is the track, and the length is 5 in this test case. So let's say the first chunk is 8C, and let's start from S, and we know that and we are in this red circle just to understand this test case, and the circular track is of length 5. So when we see 8 in clockwise direction, we will cover once the full circle, which is of 5, and then we are left with 3 more because it is 8, and we will cover 3 and reach here to complete 8, going through one lap, completing one lap, and 3 more units. And this 8 and the bracket 3 indicates that we have completed anyway one lap, but we are left with 3 from the starting point when we finish the first chunk. The second chunk is 4A. So let's start from the same position, and let's follow in the green circle to indicate that it is the chunk 2. So we are at this point, and which is covering 3 units in the clockwise direction from the start. Now we need to go 4 units in anti-clockwise direction because 4A is the second chunk. So since we are already 3 units covered from start position in clockwise direction, and now we have 4 needs to be covered in anti-clockwise direction, we will go back these 3 and reach the starting position, and now we are left with 1 more unit. So we have to go 1 unit in the anti-clockwise direction and reach this point, which is 4 minus 1. Minus 1 is just indicating that we are in the anti-clockwise direction in this chunk. So we reach this point after chunk 2. Now the third one is 5C, and yellow, we will use the yellow circle just to understand the chunk 3. So from here we have to go in clockwise direction 5 units. Since we are already minus 1 unit, that means we have crossed 1 unit from the starting position in anti-clockwise. We will go in the clockwise direction in the third chunk, covering this 1 unit and reaching the starting point. So now we are left with 4 more units. So we will cover the 4 units in the clockwise direction in yellow and reach here. So that is the final position. So we have seen that in the red, while using the first chunk, we have crossed the starting point once, counting it as 1, and we had reached here. And then in the green, we went back to starting point and then crossed it and covered 1 more unit. Since it is a directional change at the starting point, it only resets to the 0 and it doesn't count as the new lap. So we are still at 1 from the red circle. So in the third chunk, we again go towards starting point and cross it in clockwise direction, which is different from the previous one, which was anti-clockwise direction. So again it resets to 0 and not counted as a new lap, and it continues in the clockwise direction for 4 more units, and it doesn't reach the starting point. So overall we only have 1 lap covered in the chunk. So the answer should be 1. So that is indicated here as case #1:. Let's look at the algorithm. So instead of counting the laps whenever it crosses the starting point, we can try to simplify this problem by counting the distance and accumulating it whenever the direction stays in the same direction. whether clockwise or anti-clockwise. So we will keep on accumulating the distance from each chunk if the direction remains the same. And whenever the distance changes, we will calculate the number of laps from the previous accumulated distance and see what is left in the distance, so that we can count it in the negative way to go back to the starting point since the direction has changed. And while calculating for the number of laps from the accumulated distance, we can use the integer division from L to get it, and the extra distance we can get it from the modulo L for the accumulated distance. And for the next batch of accumulation, since the direction changes, we will consider the previous remaining extra distance in a negative way, because we need to go back to the starting point in the different direction to reach 0. And this will take care of any alternating directional changes without reaching the starting point. Let's look at the template of the code. So we have the main code where we are going through each test case, and we will call the solve test case. And in the solve, we need to read the input, and we will have the result as 0, and we will need to have the algorithm implemented here to find out the result, and we will print out the result where we will just print case -t and the result. So this is the template, and let's look at the code. And this is the initialization related code. In the solve, we need to first read the input. We will read L and N, and then we need to read each of the chunk where we want to read the distance D covered as part of that chunk run, and the directional of the running C. And we will use a struct item with D for int64 and C with character. And we will store it in a vector of item which is of size n, because we will have having the n chunks of runs. And we will go through I0 to n-1, and we will read runs of I into D and C. So this is the initialization related code, and the main algorithm code is this. So laps is the final number of laps counted by the machine, and let's initialize it to 0. And as we discussed in the algorithm, we want to know the current direction. Let's say that is current underscore direction, and also we keep on accumulating the distance for the current direction until it changes the direction. So let's call it as temp run distance, and we will initialize these two to the first run chunk, which is runs of 0 C and runs of 0 D. Then we will go through the loop from 1 to n-1, because 0 is used here as the initialization. Now if the new direction in the chunk is same as the current direction, we don't do anything else. We will just accumulate the temp run distance by adding the runs of I, D. If the direction changes, then we need to calculate the laps. So we will add to the already counted laps by temp run distance divided by integer division from L. So this will give how many laps have elapsed in the current direction. And then we need to find out what is left out for completing those laps, which is less than L. That extra distance which is less than L is computed with the modulo L to the temp run distance. And now the new direction is in the runs I of C, and the new temp run distance is not just the D from the new chunk run, but we need to subtract the extra distance left out in the previous accumulated distance, because we need to go back in the different direction towards the starting point before starting counting for the new lap. And once we exit this for loop, there may be the accumulated temp run distance that we need to take care. So we will again do this to adding to the counting the number of laps and adding to the laps and print this out. And let's take a look at the test case and the submit. So for this we tried the test 1 and test 2, test set 1, test set 2, which completed successfully, and also the first attempt of submission succeeded for both test set 1 and 2 in the first attempt, and the points scored is 15 for the running in circles. And some tips from this problem will be we need to think about the state that we want to maintain. In this case, since the direction will be changing, we definitely want to know the previous direction, because that's what even the machine is doing. And we need to accumulate the distance in the current direction. So we can think about these two as a state of this problem that we need to maintain as part of the code. And we will also think about what is the main event, which is the direction change, which triggers what to do with the processing, because that is when we need to do the processing. So it's more about identifying what is that main event which triggers the change in the some critical change in the state, so that we need to do some main processing. And then we need to calculate the distance whenever the direction changes accurately. It's like the corner case is about the plus minus thing of the direction covered in each chunk, because it may not be that there may be multiple chunks alternating between these two directions without crossing the starting line with smaller chunks of direction. So that is another special case we need to be aware of while calculating. This is about the subtracting the previous left out extra distance. So that's it about solving problem 1. And if you find this useful, please like, subscribe and share, and thank you for watching.